Today we're going to dive into a foundational topic in molecular biology, primer design. Primers are essential for techniques like CR, where they allow us to amplify specific DNA region. This video will cover the basics of primer design and introduce some useful databases to help you design primers for your experiment. So what exactly is a primer? A primer is a short, single-stranded piece of DNA that binds to a specific sequence on the target DNA. It serves as the starting point for DNA polymerase to replicate the desired region. In CR, primers are critical because they define the beginning and end of the DNA segment you want to amplify. When designing a primer, there are three main factors to keep in mind. First, the length of the primer, which is usually between 18 and 25 nucleotides. This ensures specificity to the target without unintended bindings. Second, GC content, which should ideally be between 40% and 60%. Guanine G and cytosine C. Bases form stronger bonds, which provide stability for primer binding. Finally, the melting temperature, or TM, should be around 50-60. This temperature ensures efficient binding during CR without causing mismatches. Now let's talk about common mistakes to avoid in primer design. Avoid self-complementarity, which can cause primers to bind to themselves, creating structures called dimers. Also, avoid repetitive sequences like long runs of the same base, as these can lead to unstable binding. Finally, make sure there's no overlap between your forward and reverse primers, as this can lead to unintended primer-dimer formation. Now, let's briefly look at some databases and tools that simplify primer design. Mengi Primer Blast allows you to design and check primers against a specific genome to avoid off-target binding. Primer3 is an open-source tool widely used for designing custom primers with adjustable parameters. 8. OligoAnalyzer helps in checking primer properties like melting temperature and secondary structures. These resources can help you design primers with the precision needed for high-quality results. To wrap up, a well-designed primer should be specific to the target sequence, stable in binding, and efficient for amplification. With these basics and the right tools, you're ready to start designing primers for your experiment.